Hello. Today we're going to talk about Topic 4, Section 9, the normal distribution. So what you have in front of you is the normal bell curve. Okay? What that means is the mean is 0 and the standard deviation is 1. Okay? And what this says over here is the probability that you are 1 less than the mean, and 1 standard deviation less than the mean, and 1 standard deviation above the mean. So that would be from here to here, because this represents 1 standard deviation. This represents your mean. So from here to here, that's 68%. Okay, which makes sense because this light blue area represents a lot. Okay, that shaded area is quite a bit of the graph. But now if I go 2 standard deviations, okay, now I'm going from here to here. Well, that's a lot, including the lightest blue and the middle blue, so now we're at 95%. Okay, and now the final one is going 3 standard deviations. So from here to here, that is 99.7%. So nearly all of your data, all of your distribution, all of whatever, should be within 3 standard deviations. Past that, it's kind of amazing that it would happen. It's an outlier. Well, not necessarily an outlier, but it's very unlikely to have occurred. Okay? Now, we can shift the normal distribution. Okay? We can move it left and right, so the mean doesn't have to be 0. By moving it left and right, we just add or subtract to the mean. Okay, so the mean is just shifting the whole thing left and right. Now, if we want to make it more spread out, okay, so a much wider curve, then we would increase the standard deviation. Right? You're increasing the variability in your numbers. Right? When you decrease that standard deviation, it brings your numbers closer together and doesn't let them vary very much. I know, that sounds weird. Okay. Okay, so the best way to do anything is with an example. So here we have all this information. Okay, so what this means is you have a normal distribution with a mean of 12 and some standard deviation. Okay, you know the probability that x is less than 11 and the probability of x being greater than 14. So now you want to find the following. I am much better when it comes to visualizing things. So draw your normal curve. Okay, you know your mean is 12, and you know probability is less than 11 and greater than 14. So less than 11, we know this probability to the left is 0.369. To the right, greater than 14, is this. Okay, I want to find the probability that it's greater than 11. Well, greater than 11 would be from here to there. Okay, well, we should know that's basically the complement of less than 11. Okay, I should know that the probability that x is less than 11 plus the probability of x being greater than 11 should equal 1. So 0.369 plus this probability must equal 1. Therefore, this should equal 0.631. Okay, so that's for part A. Now for part B, okay, I want the probability for x to be in between 11 and 14. So that's this area right here. So I should know, all right, I'm going to do this one down here, that this one is 0.369 plus the probability between 11 and 14 plus 0.252 should equal 1. that the only way to get it? No, but that's how my brain did it. Okay, I like to visualize things. I use different colors. I encourage you to do the same. Okay, there are such things as erasable highlighters. I encourage you to invest in some. Okay, they're kind of handy. Okay, so then let's see. You solve this one. So the probability that it is in between there is 0.379. Now, part C. All right, the approximate percentile of x equals 14. When we discuss percentiles, we're talking about that number and below. Like if you were ranked in the 70th percentile, that means you did better than 70% of the people who participated. Okay, so if we want the percentile of x equals 14, we want the probability of x being less than 14. Okay, well, we know the probability of it being greater than 14, so we just need to do 1 minus that. Okay, knowing complements is really useful. Okay, so we do 1 minus 0.252, and therefore our answer should be 0.748. So it wanted as a percentile, so put it as a percent. So that would be 74.8 is below it, so then we would go the 75th percentile. Okay, better than 74.8, well, you're better than 74%, so then you would say you're in the 75th percentile. Okay, always use context when you're trying to figure out what your answer should be written as. All right, so now we do another example. So here it states that the mean is 1.8. Our standard deviation is 0.5, right? Because we usually talk about variance, which is standard deviation squared. So we want to find the interval around the mean. So centered around the mean. So if I've got my normal distribution, I want to be centered around my mean that contains the weights of approximately 68%. So that means I want 34% over here, 34% over here, and I want all of that. So I want that to be 68%. Well, hopefully we know that percentage is just one standard deviation from the mean. So if we're trying to write our interval, okay, we need to take our mean and subtract one standard deviation. Oh, sorry, I guess I should keep using my variables. Minus one standard deviation. So 1.8 minus 0.5, so we get 1.3. Then take your mean and add one standard deviation. So then we get 2.3. So this interval has to be around the mean of 1.8 and go from 1.3 to 2.3. So we write that as the probability that x is between 1.3 and 1.8 is, approximately 68%. Okay. If that doesn't make sense, please talk to me. We need to know how to translate from this math text to real world. Okay, that's all what A&I is applications. Okay, so now for example 3. So, Yasmin gets to go to school with a normal distribution of 35 minutes and a standard deviation of 2.5 minutes. All right, she is 99.7% confident that it will take her at least 27.5 minutes and less than some amount of minutes to make it to school. So find T. All right, well, think about what you have here. You have your normal distribution, you have this is 35, and you know with 99.7% confident that it's in between the interval of 27.5 and some value t. Well, hopefully this rings a bell. All right, but if not, this should tell you too, the standard deviation is 2.5. So go down 2.5, we're at 32.5, then we're at 30, and then bam, we're at 27.5. That is 3 standard deviations below the mean. So therefore, we need to go the opposite direction to get the other interval, okay? Because that is within 3 standard deviations, is in 99.7% probability, okay? So add your 2.5, we get 37.5, we get 40, and then we get 42.5. There you go. So now example 4, we have the number of chocolates in a bag, normally distributed with a mean of 43. So I'm all about the visual, and a standard deviation of 3. So that's going to be 40, that's going to be 37, that's going to be 34, and we can go for symmetry here, 52. Okay. So we did the mean here, and then, did that rough. 1 standard deviation, 2, 3, right? We want to know the probability that there are more than 37 chocolates in the bag. Okay, well, 37 chocolates in the bag, more than 37. So 37 is here. We want to have more. Okay. So let's think about what that means, okay? You should know that within 2 standard deviations, right? Within 2 standard deviations, there is a 95% probability, which means the other side is 5%. So this side is 2.5, and this side is 2.5. Okay? So, we want to know what the probability of this blue part here plus this piece here. So, 95% plus 2.5% is equal to 97.5%. Bam, that's all you got to do. See how I showed my work with my example? Don't just not draw anything, okay? That's how I showed it. Cognigy also has it so you can write it out as in probabilities. You can do that too. Okay, so your probability density function, so your area under the curve. So what if it doesn't follow your normal standard deviations? Okay, what are you going to do? Well, you can use this fun, really simple formula, right? Totally looks easy enough, right? Okay. Couple things you want to notice. In theory, it goes, it includes all the numbers from negative infinity to infinity. If you haven't seen this symbol yet, that is an integral. We'll get to that with calculus. But it includes all these numbers. In the real world, there may be limitations, okay? But in theory, it all remains the same, okay? So think about real-world applications when you do things. Now, fun fact, you will not have to memorize this formula. Your calculator will do things for you, so make sure you know how to use your calculator, okay? Okay, so knowing how to use your calculator is super duper important, all right? It's going to help you solve these problems in no time. It's very unlikely that normal distribution will not be on the IB exam, so you really want to make sure you've got this down. So for the first one, we want a probability in between this interval. So we can do, let's see, where is it? Nope, not there. Second vars. Yeah. Okay, so second vars. And then you want to do the normal CDF because we've got an interval. We're using CDF. CDF is for intervals. So we want to go from 1.2 is the lower. The upper bound is 3.5. The mean is 2, and the standard deviation is 1.5. So we paste that. Okay. If your calculator doesn't put it in that order, and you just have to write it out, if you have one of those older calculators, just follow exactly how we typed it in, or how I mentioned it. Okay, so here you get a probability of 0.54. Great. Okay, so perfect. We didn't have to do it with standard deviations. The calculator did it for us. All right, what about if we don't have a left and right? Okay, so we do second vars. We still do normal CDF. But now our lower bound, we're going to make it the lowest number we can think of. So -10 to the 99th power. That should seem low enough for us. Okay? All right, especially when our mean is 2 and our standard deviation is 1.5. That seems like an awfully far, far number. Okay, so even though it's not the absolute edge, it's close enough. Okay, it's going to get enough of our tail. Okay, so then our upper bound is 1.2, and everything else is the same. And there's our probability. So what about less than 0.5 and greater than 0.35, or I'm sorry, 3.5, so either or to happen? Well, here you can notice that they are the same number of standard deviations above and below, right? To minus 1.5. I guess I should write this out. Okay, so notice that it's 2 minus 1.5 is 0.5, and 2 plus 1.5 is 0.5. So these probabilities should be equal. So I'm just going to find one and double it. Okay, that's what I'm trying to get at. You could do both differently and then add them together, but it should be the same. So I'm just going to do 2 times a normal distribution. Since I already have the lower bound, I'm going to do the left side. So from there to 0.5. Okay, we're going to paste that in there. And since we already did 2 times it, we get that answer. Okay, so then you want to go ahead and write those in. So let's see, this answer was 0.544. This answer is 0.297. We're going to 3 sig figs. Oop, didn't mean to erase the 0 there. And then this one is 0.317. All right, so now let's continue with doing these probabilities. Okay, so what if you know the area, but you want to find the x value? Okay, so what that interval is going to be. All right, I really think you're going to like this. Oh, didn't mean to make that go away. So we go to second vars, and now we're going to do the inverse norm. Okay, so we're doing the inverse. We don't know what the interval is, but we know what the area is. So the area is 0.72. The mean is 2.2, and our standard deviation is 0.5. So let's find that. Okay, so notice that my calculator didn't tell me where this area was happening. Some of you may have had the option to choose left, center, or right. My calculator in this video automatically puts that area to the left. So it automatically does it like this, where this area is 0.72. Okay, that is left. All right, now some of you guys may have given the option if you had chosen, let me see if I can write this out. If you had chosen center, it would have done this as 0.72. And if you had chosen the right, it would have done this area as 0.72. Okay, so my calculator again didn't give me the option on screen. However, this calculator, this calculator does give you that option. Okay, so my calculator automatically did the left-hand side, which is great because that's exactly what I wanted here. Okay, so I got 0.72. So, to the left, well, obviously, because that's what I had, but the number is 2.49. So that means this value right here is 2.49. Okay? So find the value of b, so that interval there. Okay, so now let's do the next one. Okay, so for this one, we want to find the value of b such that b is greater. So we want it on the right-hand side. We want it to be this, is 0.43. So what I'm actually going to do is I'm going to find this value and do 1 minus that probability. Okay? So that probability, I'm sorry, that should be greater than b. Ooh, what am I saying? Okay, so that is just 1 minus 0.43. So we get, what is that, 0.57. Okay, so we want the probability on that side. So now we can find the interval that way using my calculator. Okay, so on my calculator, because I can't change it on yours, you guys could just use the left, center, right, and keep everything else the same. But since I can't on mine, I'm going to show you how to change it. So inverse norm, the area is now 0.57 with the left side, 2.2, 0.5, paste. So we get 2.29 if we were to round that. Okay, so this this value b ends up being 2.29. Okay. All right, so let's do another example. Why don't you guys see if you guys can figure this out? Okay. Again, some of you guys might have it easier with the newer calculators because you can choose that center bound. But actually it may not be perfectly centered, so I wouldn't do it that way. Ooh. Okay, anyway, so if you've tried it and now you don't know, now let me help you walk you through it. Okay, so I'm a visual person. I'm going to say that every single time. Okay, so 2.2, standard deviation of 0.5, yada, yada, yada. We want some interval from 1.8 to some value. Okay, so 1.8, well, that's 2 standard deviations lower. So that's approximately here. Oh, no, that's more than... What am I saying? That's like 1 standard deviation. I'm so silly. Let me draw this a little better to scale. Okay, so 1.8, and then I'm going to go to some value of b, so probably more this way. So it's probably not going to be centered because that value, trying to get it all, is 0.6. Okay, well, lucky us, we have everything we need to find this value. Ooh, let me change my color. To find this. So the probability that x is less than 1.8, okay, we can use our formula. So use that normal CDF. So we get to 3 significant figures, 0.212. Again, if you're confused, second vars, go to normal CDF because it's an interval. lower value really low, then to 1.8. The mean is 2.2, and the standard deviation is 0.5. Paste 2.12. Okay, so that's that part. All right, so now we know the probability of this green part. Okay, so stay with me here. The probability that x is less than b, well, that's just the probability of x being less than 1.8, the red part, plus the probability x is between 1.8 and b, the purple part. So that's just 0.212 plus 0.6, which is 0.812. So now we know the probability of x being less than b, right? Approximately, because we rounded this stuff. All right. Now we can use the inverse norm. Okay, so going to our calculator. So second vars, the inverse norm, we want the area to be 0.812. The mean is 2.2. The standard deviation is 0.5. We paste it. We get 2.64. So that means using the inverse norm on the calculator, we get B is 2.64, well, approximately. All right, so this is what you should know by the end of this subtopic. I hope this makes sense. If you have any questions, please feel free to ask me. Don't hesitate. I promise you're not alone.